Hello, today's section is on section 2.5, how do you model a direct variation? So direct variation is in the form y equals a times x. And we say y varies directly with x. So as x increases, y is going to increase. As x decreases, y decreases. So y varies directly with x. The constant here, the coefficient, is called a constant of variation. It's also the slope. Okay, and if I was to graph this, it would go through 0, 0 because there is no y-intercept here. There is no plus b at the end. Okay, so the a is the slope, goes through 0, 0. Okay, so these are pretty simple to graph. Okay, a lot of things vary directly. For example, think of your favorite food in the cafeteria. What does it cost? Well, your bill is going to be whatever the cost is, which would be the constant. The cost of a cheeseburger doesn't change, times x, which would be how many you order. So if I order 2 cheeseburgers and they're $3 each, 2 times 3 would be a $6 bill. Okay, your wage typically varies directly. So your pay equals your hourly pay times the hours worked. So pay varies directly with hours worked. The more hours I work, the bigger my paycheck is. Okay, your hourly pay, your hourly wage doesn't change. So graphing these. So if I'm given a point, I can find the equation and I can graph it. So if I know that 3, -9 is a point on a direct variation, I can find the equation of that and I can graph that as well. So 3, -9 way down here, and I know it goes through 0, 0. So this is just a quick sketch of my graph. But if I have y equals ax and I want to find the equation of that line, all I simply do is plug 3 in for x, 9 in for y, and solve for a. Divide both sides by 3 and I get -3. So my equation will be y equals -3x. Okay, let's try another one. -7, 4. Okay, so I could graph that and that's pretty simple, but what if I want to find the equation? Okay, well, plug -7 in for x, 4 in for y. Okay, in this case, if I divide by -7, I get a fraction there. So a is -4/7. I just leave it as a fraction. So I get y equals -4/7 x. Okay, leaving it as a fraction is better because it's more useful than a decimal in this situation. Okay. Let's look at an application problem. In physics, you'll come up with this law called Hooke's law, which states that the distance a spring stretches varies directly with the force that's applied to it. So the distance varies directly with the force. So that's how you'd write the, whoops, I'm off the page. So Hooke's law says that for a spring, the distance varies directly with the force. So let's say we have a spring and it stretches 15 inches when I put a force of 9 pounds on it. What is the equation for that spring? What is the direct variation equation? So all I have to do is substitute these values in. 15 in for D, 9 in for F. Divide, I get 15 over 9. We can simplify that down to 5/3. So in this case, fix this here. So D is going to equal 5/3 F. Okay, so now we can use that information to predict, okay, now what if I put a force of 6 pounds on it? How far is that spring going to stretch? Okay, so now I can plug that right into the equation. So now that I did an experiment for that spring, I can substitute any value in for the force and figure out what the distance it's going to stretch is. So in that case, the distance is going to be 30 divided by 3 is 10 inches. That's where it comes in handy. Okay, looking at a table of values. So given a table, is it a direct variation? So let me make an example here. XY table. Let's say 1, 2, 3, 4, 3, 6, 9, 12. So to make it a direct variation, every ratio of the y over the x must be equal. So if I go down the list here, if I take my y value over my x value and the result is the same, that means it's a direct variation. Okay, so 3 divided by 1 is 3, 6 divided by 2 is 3, 9 divided by 3 is 3, 12 divided by 4 is 3. So this is a direct variation, and the equation, that constant division there, the constant result, is your constant of variation, y equals 3x. Okay. If I look at the pattern here, if I went to 0, I don't have room for 0, but if I keep going down by 3, I get 0, 0. So you can see that it goes through 0, 0, so that would indicate that it's a direct variation. Okay, as opposed to this chart, let's do another one. In this case, every y over x is not equal. 3 divided by 1 is 3. 5 divided by 2 is 2.5. You can see that they're not equal. So this is not a direct variation. And if I look at the pattern here, and if I went up to 0 here, what would the y value be for 0? Well, I'm dropping by 2 each time, so 0 would be 1. So that shows you that it doesn't go through 0, 0 like a direct variation equation is supposed to. The actual equation for this one, I believe, would be 2x plus 1. Okay, so that's not a direct variation. So this one is. That is it for section 2.5 on direct variation.